Merlin, empowering multimodal LLMs with foresight minds. Humans possess the remarkable ability to foresee the future to a certain extent based on present observations, a skill we term as foresight minds. However, this capability remains largely underexplored within existing multimodal large language models, LLMs, hindering their capacity to learn the fundamental principles of how things operate and the intentions behind the observed subjects. To address this issue, we introduce the integration of future modeling into the existing learning frameworks of LLMs. By utilizing the subject trajectory, a highly structured representation of a consecutive frame sequence, as a learning objective, we aim to bridge the gap between the past and the future. We propose two innovative methods to empower LLMs with foresight minds: Foresight Pre-Training, FPT, and Foresight Instruction Tuning, FIT, which are inspired by the modern learning paradigm of LLMs. Specifically, FPT jointly training various tasks centered on trajectories, enabling LLMs to learn how to attend and predict entire trajectories from a given initial observation. Then, FIT requires LLMs to first predict trajectories of related objects, and then reason about potential future events based on them. Aided by FPT and FIT, we build a novel and unified LLM named Merlin that supports multi-images input and analysis about potential actions of multiple objects for the future reasoning. Experimental results show Merlin powerful foresight minds with impressive performance on both future reasoning and visual comprehension tasks. SeaLLMs, large language models for Southeast Asia. Despite the remarkable achievements of large language models, LLMs, in various tasks, there remains a linguistic bias that favors high-resource languages such as English, often at the expense of low-resource and regional languages. To address this imbalance, we introduce SeaLLMs, an innovative series of language models that specifically focuses on Southeast Asian, CA languages. SeaLLMs are built upon the Llama 2 model and further advanced through continued pre-training with an extended vocabulary, specialized instruction and alignment tuning to better capture the intricacies of regional languages. This allows them to respect and reflect local cultural norms, customs, stylistic preferences, and legal considerations. Our comprehensive evaluation demonstrates that SeaLLM 13B models exhibit superior performance across a wide spectrum of linguistic tasks and assistant-style instruction following capabilities relative to comparable open-source models. Moreover, they outperform ChatGPT 3.5 in non-Latin languages, such as Thai, Khmer, Lao, and Burmese, by large margins while remaining lightweight and cost-effective to operate. VideoBooth, diffusion-based video generation with image prompts. Text-driven video generation witnesses rapid progress. However, merely using text prompts is not enough to depict the desired subject appearance that accurately aligns with users' intents, especially for customized content creation. In this paper, we study the task of video generation with image prompts, which provide more accurate and direct content control beyond the text prompts. Specifically, we propose a feed-forward framework called VideoBooth with two dedicated designs. 1. We propose to embed image prompts in a coarse-to-fine manner. Coarse visual embeddings from Image Encoder provide high-level encodings of image prompts, while fine visual embeddings from the proposed attention injection module provide multi-scale and detailed encoding of image prompts. These two complementary embeddings can faithfully capture the desired appearance. 2. In the attention injection module at the fine level, multi-scale image prompts are fed into different cross-frame attention layers as additional keys and values. This extra spatial information refines the details in the first frame, and then it is propagated to the remaining frames, which maintains temporal consistency. Extensive experiments demonstrate that VideoBooth achieves state-of-the-art performance in generating customized high-quality videos with subjects specified in image prompts. Notably, VideoBooth is a generalizable framework where a single model works for a wide range of image prompts with a feed-forward pass. GraphDreamer, Compositional 3D Scene Synthesis from Scene Graphs. As pre-trained text-to-image diffusion models become increasingly powerful, recent efforts have been made to distill knowledge from these text-to-image pre-trained models for optimizing a text-guided 3D model. Most of the existing methods generate a holistic 3D model from a plain text input. This can be problematic when the text describes a complex scene with multiple objects, because the vectorized text embeddings are inherently unable to capture a complex description with multiple entities and relationships. Holistic 3D modeling of the entire scene further prevents accurate grounding of text entities and concepts. To address this limitation, we propose GraphDreamer, a novel framework to generate compositional 3D scenes from scene graphs, where objects are represented as nodes and their interactions as edges. By exploiting node and edge information in scene graphs, our method makes better use of the pre-trained text-to-image diffusion model and is able to fully disentangle different objects without image-level supervision. To facilitate modeling of object-wise relationships, we use signed distance fields as representation and impose a constraint to avoid interpenetration of objects. To avoid manual scene graph creation, we design a text prompt for ChatGPT to generate scene graphs based on text inputs. We conduct both qualitative and quantitative experiments to validate the effectiveness of GraphDreamer in generating high-fidelity compositional 3D scenes with disentangled object entities. Mamba, linear time sequence modeling with selective state spaces. Foundation models, now powering most of the exciting applications in deep learning, are almost universally based on the transformer architecture and its core attention module. Many subquadratic time architectures, such as linear attention, gated convolution, and recurrent models, and structured state space models, SSMs, have been developed to address transformers' computational inefficiency on long sequences, but they have not performed as well as attention on important modalities, such as language. We identify that a key weakness of such models is their inability to perform content-based reasoning, and make several improvements. First, simply letting the SSM parameters be functions of the input addresses their weakness with discrete modalities, allowing the model to selectively propagate or forget information along the sequence length dimension, depending on the current token. Second, even though this change prevents the use of efficient convolutions, we design a hardware-aware parallel algorithm in recurrent mode. We integrate these selective SSMs into a simplified end-to-end neural network architecture without attention or even MLP blocks, Mamba. Mamba enjoys fast inference, 5 times higher throughput than transformers, and linear scaling in sequence length, and its performance improves on real data up to million-length sequences. As a general sequence model backbone, Mamba achieves state-of-the-art performance across several modalities, such as language, audio, and genomics. On language modeling, our Mamba 3B model outperforms transformers of the same size and matches transformers twice its size, both in pre-training and downstream evaluation. StyleCrafter, enhancing stylized text-to-video generation with style adapter. Text-to-video T2V models have shown remarkable capabilities in generating diverse videos. However, they struggle to produce user-desired stylized videos due to text's inherent clumsiness in expressing specific styles and the generally degraded style fidelity. To address these challenges, we introduce StyleCrafter, a generic method that enhances pre-trained T2V models with a style control adapter, enabling video generation in any style by providing a reference image. Considering the scarcity of stylized video datasets, we propose to first train a style control adapter using style-rich image datasets, then transfer the learned stylization ability to video generation through a tailor-made fine-tuning paradigm. To promote content style disentanglement, we remove style descriptions from the text prompt and extract style information solely from the reference image using a decoupling learning strategy. Additionally, we design a scale-adaptive fusion module to balance the influences of text-based content features and image-based style features, which helps generalization across various text and style combinations. StyleCrafter efficiently generates high-quality stylized videos that align with the content of the texts and resemble the style of the reference images. Experiments demonstrate that our approach is more flexible and efficient than existing competitors. Beyond chatbots, ExploreLLM for structured thoughts and personalized model responses. Large language model, LLM-powered chatbots are primarily text-based today and impose a large interactional cognitive load, especially for exploratory or sense-making tasks, such as planning a trip or learning about a new city. Because the interaction is textual, users have little scaffolding in the way of structure, informational scent, or ability to specify high-level preferences or goals. We introduce ExploreLLM that allows users to structure thoughts, help explore different options, navigate through the choices and recommendations, and to more easily steer models to generate more personalized responses. We conduct a user study and show that users find it helpful to use ExploreLLM for exploratory or planning tasks, because it provides a useful schema-like structure to the task and guides users in planning. The study also suggests that users can more easily personalize responses with high-level preferences with ExploreLLM. Together, ExploreLLM points to a future where users interact with LLMs beyond the form of chatbots, and instead designed to support complex user tasks with a tighter integration between natural language and graphical user interfaces. Dolphins, multimodal language model for driving. The quest for fully autonomous vehicles, AVs, capable of navigating complex real-world scenarios with human-like understanding and responsiveness. In this paper, we introduced Dolphins, a novel vision language model architected to imbibe human-like abilities as a conversational driving assistant. Dolphins is adept at processing multimodal inputs comprising video or image data, text instructions, and historical control signals to generate informed outputs corresponding to the provided instructions. Building upon the open-sourced pre-trained vision language model, OpenFlamingo, we first enhanced Dolphins' reasoning capabilities through an innovative grounded chain of thought, or GCOT process. Then we tailored Dolphins to the driving domain by constructing driving-specific instruction data and conducting instruction tuning. Through the utilization of the BDDX dataset, we designed and consolidated 4 distinct AV tasks into Dolphins to foster a holistic understanding of intricate driving scenarios. As a result, the distinctive features of Dolphins are characterized into 2 dimensions. 1. The ability to provide a comprehensive understanding of complex and long-tailed open-world driving scenarios and solve a spectrum of AV tasks. And 2. The emergence of human-like capabilities, including gradient-free instant adaptation via in-context learning and error recovery via reflection. MoMask, generative masked modeling of 3D human motions. We introduce MoMask, a novel mask modeling framework for text-driven 3D human motion generation. In MoMask, a hierarchical quantization scheme is employed to represent human motion as multi-layer discrete motion tokens with high-fidelity details. Starting at the base layer with a sequence of motion tokens obtained by vector quantization, the residual tokens of increasing orders are derived and stored at the subsequent layers of the hierarchy. This is consequently followed by 2 distinct bidirectional transformers. For the base layer motion tokens, a masked transformer is designated to predict randomly masked motion tokens conditioned on text input at training stage. During generation, that is inference stage, starting from an empty sequence, our masked transformer iteratively fills up the missing tokens. Subsequently, a residual transformer learns to progressively predict the next layer tokens based on the results from the current layer. Extensive experiments demonstrate that MoMask outperforms the state-of-art methods on the text-to-motion generation task, with an FID of 0.045 versus, for example, 0.141 of T2M GPT on the human ML 3D dataset, and 0.228 versus 0.514 on KitML, respectively. MoMask can also be seamlessly applied in related tasks without further model fine-tuning, such as text-guided temporal inpainting. HiFi Tuner, high-fidelity subject-driven fine-tuning for diffusion models. This paper explores advancements in high-fidelity personalized image generation through the utilization of pre-trained text-to-image diffusion models. While previous approaches have made significant strides in generating versatile scenes based on text descriptions and a few input images, challenges persist in maintaining the subject fidelity within the generated images. In this work, we introduce an innovative algorithm named HiFi Tuner to enhance the appearance preservation of objects during personalized image generation. Our proposed method employs a parameter-efficient fine-tuning framework comprising a denoising process and a pivotal inversion process. Key enhancements include the utilization of mask guidance, a novel parameter regularization technique, and the incorporation of stepwise subject representations to elevate the sample fidelity. Additionally, we propose a reference-guided generation approach that leverages the pivotal inversion of a reference image to mitigate unwanted subject variations and artifacts. We further extend our method to a novel image editing task, substituting the subject in an image through textual manipulations. Experimental evaluations conducted on the DreamBooth dataset using the Stable Diffusion model showcase promising results. Fine-tuning solely on textual embeddings improves ClipT score by 3.6 points and improves Dino score by 9.6 points over textual inversion. When fine-tuning all parameters, HiFi Tuner improves ClipT score by 1.2 points and improves Dino score by 1.2 points over DreamBooth, establishing a new state-of-the-art. Instruction tuning aligns LLMs to the human brain. Instruction tuning is a widely adopted method of fine-tuning that enables large language models, LLMs, to generate output that more closely resembles human responses to natural language queries, in many cases leading to human-level performance on diverse test beds. However, it remains unclear whether instruction tuning truly makes LLMs more similar to how humans process language. We investigate the effect of instruction tuning on LLM human similarity in two ways. 1. Brain alignment. The similarity of LLM internal representations to neural activity in the human language system. And 2. Behavioral alignment. The similarity of LLM and human behavior on a reading task. We assess 25 vanilla and instruction-tuned LLMs across 3 datasets involving humans reading naturalistic stories and sentences. We discover that instruction tuning generally enhances brain alignment by an average of 6%, but does not have a similar effect on behavioral alignment. To identify the factors underlying LLM brain alignment, we compute correlations between the brain alignment of LLMs and various model properties, such as model size, various problem-solving abilities, and performance on tasks requiring world knowledge spanning various domains. Notably, we find a strong positive correlation between brain alignment and model size, or equal sign 0.95, as well as performance on tasks requiring world knowledge, or equal sign 0.81. Our results demonstrate that instruction tuning LLMs improves both world knowledge representations and brain alignment, suggesting that mechanisms that encode world knowledge in LLMs also improve representational alignment to the human brain. Towards accurate differential diagnosis with large language models. An accurate differential diagnosis, DDX, is a cornerstone of medical care, often reached through an iterative process of interpretation that combines clinical history, physical examination, investigations and procedures. Interactive interfaces powered by large language models, LLMs, present new opportunities to both assist and automate aspects of this process. In this study, we introduce an LLM optimized for diagnostic reasoning and evaluate its ability to generate a DDX alone or as an aid to clinicians. 20 clinicians evaluated 302 challenging, real-world medical cases sourced from the New England Journal of Medicine, NEJM case reports. Each case report was read by 2 clinicians who were randomized to one of 2 assistive conditions, either assistance from search engines and standard medical resources or LLM assistance in addition to these tools. All clinicians provided a baseline unassisted DDX prior to using the respective assistive tools. Our LLM for DDX exhibited standalone performance that exceeded that of unassisted clinicians. Top 10 accuracy 59.1% versus 33.6%. P = 0.004. Comparing the 2 assisted study arms, the DDX quality score was higher for clinicians assisted by our LLM, top 10 accuracy 51.7%, compared to clinicians without its assistance, 36.1%, McNemar's test, 45.7, p less than 0.01, and clinicians with search, 44.4%, 4.75, p = 0.03. Further, clinicians assisted by our LLM arrived at more comprehensive differential lists than those without its assistance. Our study suggests that our LLM for DDX has potential to improve clinicians' diagnostic reasoning and accuracy in challenging cases, meriting further real-world evaluation for its ability to empower physicians and widen patients' access to specialist-level expertise. DREAM, Diffusion, Rectification and Estimation Adaptive Models. We present DREAM, a novel training framework representing diffusion rectification and estimation adaptive models, requiring minimal code changes, just 3 lines, yet significantly enhancing the alignment of training with sampling in diffusion models. DREAM features 2 components: diffusion rectification, which adjusts training to reflect the sampling process, and estimation adaptation, which balances perception against distortion. When applied to image super-resolution (SR), DREAM adeptly navigates the trade-off between minimizing distortion and preserving high image quality. Experiments demonstrate DREAM's superiority over standard diffusion-based SR methods, showing a 2 to 3 times faster training convergence and a 10 to 20 times reduction in necessary sampling steps to achieve comparable or superior results. We hope DREAM will inspire a rethinking of diffusion model training paradigms. Text-guided 3D face synthesis, from generation to editing. Text-guided 3D face synthesis has achieved remarkable results by leveraging text-to-image (T2I) diffusion models. However, most existing works focus solely on the direct generation, ignoring the editing, restricting them from synthesizing customized 3D faces through iterative adjustments. In this paper, we propose a unified text-guided framework from face generation to editing. In the generation stage, we propose a geometry texture decoupled generation to mitigate the loss of geometric details caused by coupling. Besides, decoupling enables us to utilize the generated geometry as a condition for texture generation, yielding highly geometry texture-aligned results. We further employ a fine-tuned texture diffusion model to enhance texture quality in both RGB and YUV space. In the editing stage, we first employ a pre-trained diffusion model to update facial geometry or texture based on the texts. To enable sequential editing, we introduce a UV domain consistency preservation regularization, preventing unintentional changes to irrelevant facial attributes. Besides, we propose a self-guided consistency weight strategy to improve editing efficacy while preserving consistency. Through comprehensive experiments, we showcase our method's superiority in face synthesis. Project page, project's website. XDreamer, creating high-quality 3D content by bridging the domain gap between text to 2D and text to 3D generation. In recent times, automatic text to 3D content creation has made significant progress, driven by the development of pre-trained 2D diffusion models. Existing text to 3D methods typically optimize the 3D representation to ensure that the rendered image aligns well with the given text, as evaluated by the pre-trained 2D diffusion model. Nevertheless, a substantial domain gap exists between 2D images and 3D assets, primarily attributed to variations in camera-related attributes and the exclusive presence of foreground objects. Consequently, employing 2D diffusion models directly for optimizing 3D representations may lead to suboptimal outcomes. To address this issue, we present XDreamer, a novel approach for high-quality text-to-3D content creation that effectively bridges the gap between text-to-2D and text-to-3D synthesis. The key components of XDreamer are two innovative designs: camera-guided low-rank adaptation, CG LoRa, and attention mask alignment, AMA loss. CG LoRa dynamically incorporates camera information into the pre-trained diffusion models by employing camera-dependent generation for trainable parameters. This integration enhances the alignment between the generated 3D assets and the camera's perspective. AMA loss guides the attention map of the pre-trained diffusion model using the binary mask of the 3D object, prioritizing the creation of the foreground object. This module ensures that the model focuses on generating accurate and detailed foreground objects. Extensive evaluations demonstrate the effectiveness of our proposed method compared to existing text-to-3D approaches. Our project webpage, project's website. FSGS, real-time few-shot view synthesis using Gaussian splatting. Novel view synthesis from limited observations remains an important and persistent task. However, high efficiency in existing NeRF-based few-shot view synthesis is often compromised to obtain an accurate 3D representation. To address this challenge, we propose a few-shot view synthesis framework based on 3D Gaussian splatting that enables real-time and photorealistic view synthesis with as few as 3 training views. The proposed method, dubbed FSGS, handles the extremely sparse initialized SFM points with a thoughtfully designed Gaussian unpooling process. Our method iteratively distributes new Gaussians around the most representative locations, subsequently infilling local details in vacant areas. We also integrate a large-scale pre-trained monocular depth estimator within the Gaussian's optimization process, leveraging online augmented views to guide the geometric optimization towards an optimal solution. Starting from sparse points observed from limited input viewpoints, our FSGS can accurately grow into unseen regions, comprehensively covering the scene and boosting the rendering quality of novel views. Overall, FSGS achieves state-of-the-art performance in both accuracy and rendering efficiency across diverse datasets, including LLFF, MIPNeRF 360, and Blender. Project website, project's website. Scaffold-GS, structured 3D Gaussians for view-adaptive rendering. Neural rendering methods have significantly advanced photorealistic 3D scene rendering in various academic and industrial applications. The recent 3D Gaussian splatting method has achieved the state-of-the-art rendering quality and speed, combining the benefits of both primitive-based representations and volumetric representations. However, it often leads to heavily redundant Gaussians that try to fit every training view, neglecting the underlying scene geometry. Consequently, the resulting model becomes less robust to significant view changes, textureless area, and lighting effects. We introduce Scaffold-GS, which uses anchor points to distribute local 3D Gaussians and predicts their attributes on the fly based on viewing direction and distance within the view frustum. Anchor growing and pruning strategies are developed based on the importance of neural Gaussians to reliably improve the scene coverage. We show that our method effectively reduces redundant Gaussians while delivering high-quality rendering. We also demonstrate an enhanced capability to accommodate scenes with varying levels of detail and view-dependent observations without sacrificing the rendering speed. PyNeRF, pyramidal neural radiance fields. Neural radiance fields, NeRFs, can be dramatically accelerated by spatial grid representations. However, they do not explicitly reason about scale and so introduce aliasing artifacts when reconstructing scenes captured at different camera distances. MIPNeRF and its extensions propose scale-aware renderers that project volumetric frustums rather than point samples, but such approaches rely on positional encodings that are not readily compatible with grid methods. We propose a simple modification to grid-based models by training model heads at different spatial grid resolutions. At render time, we simply use coarser grids to render samples that cover larger volumes. Our method can be easily applied to existing accelerated NeRF methods and significantly improves rendering quality, reducing error rates by 20 to 90% across synthetic and unbounded real-world scenes, while incurring minimal performance overhead, as each model head is quick to evaluate. Compared to MIPNeRF, we reduce error rates by 20% while training over 60 times faster.